Hello good day viewers. In this tutorial we want to prove that the limit of the function 1 plus 1 divided by x to the power of x, as the value of x approaches infinity, it is exactly equal to e. I would like to transform the left hand side and show that it is equal to the right hand side. So let y equal to the limit as x approaches infinity of this function 1 plus 1 divided by x raised to the power of x. Next, I want to take the natural log of both sides. We have the natural log of the left hand side. This is equal to the limit as x approaches infinity of the natural log of this function 1 plus 1 divided by x raised to the power of x. And you know, according to one of the laws of logarithm, this power can drop down to multiply, right? So we can further rearrange it as natural log of y equal to the limit as x approaches infinity of x multiplied by natural log of 1 plus 1 divided by x. And secondly, you should know that multiplying by anything is the same thing as dividing by the reciprocal of that thing. So since we are multiplying the right hand side by x, it is the same thing as dividing it by 1 divided by x. So let us rearrange it a little bit. We have the natural log of y to the left. This is equal to the limit as x approaches infinity of what? The natural log of 1 plus 1 divided by x divided by 1 divided by x. So from here we can test our limit to see whether it works. If we substitute x equal to infinity, you can see these two fractions will have larger denominators. And as the denominator becomes bigger, the whole fraction will tend to approach 0. So to the top we have natural log of 1 plus 0, which is the same thing as natural log of 1. So this is natural log of 1 divided by 0, right? And natural log of 1 is 0. So in the end we have 0 divided by 0, which is in indeterminate form. And because it is indeterminate, we can apply L'Hopital's rule by differentiating top and the bottom separately. So let's do that. If you have the natural log of 1 plus 1 divided by x, suppose we want to differentiate the whole of this prime, this is equal to, let us derive the formula first. If you have natural log of u and you wish to differentiate natural log of u, this is the same thing as 1 divided by u but multiplied by the derivative of u. This is equal to u prime divided by u. This means that we are going to differentiate the inner function, which is 1 plus 1 divided by x. Then we divide by 1 plus 1 divided by x. So let's differentiate it first. What is the derivative of 1 plus 1 divided by x? The derivative of 1 is 0, but the derivative of 1 divided by x is negative 1 divided by x squared. So we have negative 1 divided by x squared. Then we divide by the whole function, which is 1 plus 1 divided by x. This is just the derivative of the top. Let's go to the bottom. The bottom is 1 divided by x. So if you have 1 divided by x and you wish to take the derivative, it is the same thing as negative 1 divided by x squared. So it means that we are going to take the whole of this and divide it by this, because that's what we have, right? Negative 1 divided by x squared divided by 1 plus 1 divided by x. Also, you divide it by negative 1 divided by x squared. You can clearly see that this will cancel this, right? All we have is equal to 1 divided by 1 plus 1 divided by x. So this is what we have after differentiating the top and the bottom. So therefore we can substitute the whole of this with what we have here, right? Which is this. So therefore the natural log of y to the left is equal to the limit as x approaches infinity of what? 1 divided by 1 plus 1 divided by x. So from here, we can substitute x equal to infinity directly. If you substitute infinity here, the bottom will be heavier, thereby making the whole fraction to approach 0. So this is equal to natural log of y equal to 1 divided by 1 plus 0. 1 plus 0 is 1. 1 divided by 1 is 1. Therefore, natural log of y is equal to 1. But remember that natural log is a log to base e. So we can say that this is log of y with the base of e equal to 1. And from definition of logarithm, we can transform this into exponential form, right? By taking y equal to e raised to the power of 1. And you know that e raised to the power of 1 is still e, and hence y equal to e. But remember that y is what? The limit as x approaches infinity of the function 1 plus 1 divided by x raised to the power of x, which is now equal to e, and hence proved. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.